Okay guys, let us see tutorial 2, first ODE. So before we discuss the tutorial, let me remind you what we have learned in the class for the standard form of the first linear ODE. So we have a standard form for the first linear ODE, which is we have y prime plus pxy equal to qx. So this is the standard form of first linear ODE. If you see these standard forms of linear first ODE, we have a standard formula to calculate what is the solutions. So the first thing we need to do is find the integrating factor. Okay, find the integrating factor. Find the integrating factor. So integrating factors is represented as I of x. And integrating factors have a formula of exponential integrate over px dx. Okay, after you find the integrating factors, then we can directly apply the formula to find out the general solution, whereby y is equal to 1 divided by the integrating factor I1. Again, multiply with the integrations of qx multiply with the integrating factors I of x dx plus c. Okay, so this is the standard form of first linear ODE solutions. Okay, so this tutorial 2 will use this standard formula. So what we need to do is we need to identify what is the px, what is the qx, and then we calculate the integrating factors, then we find the solutions. Okay, now we see questions 1. So question 1, we have y prime equal to 4y plus x. So to write in the standard form, we have y prime minus 4y equal to x. Now identify the px. What is the px here in these differentiation equations? So the px here is minus 4 and the qx is equal to x. Okay, now we find the integrating factors, the I of x, integrating factors. So integrating factor is exponential multiplied with exponential to the power of integrations, which is this one. Okay, which is this. So this is integrations over px dx. Okay, now we substitute vx. So the vx px is equal to minus 4 dx. Okay, so if you do these integrations, then the integrating factors will be exponential minus 4x. So this is our integrating factor. Now the general solution for this, we apply the formula over here. Okay, when I apply this formula, we find the general solutions. So y is equal to 1 over the integrating factors exponential minus 4x, and then we integrate over qx px. Qx is x, qx ix, integrating factors ix is exponential minus 4x dx plus c. Okay, this is by applications of the general formula. But apply the general formula then we can find the general solutions. Now we need to do the integrations of this part over here. Okay, so to do these integrations, what we need to do is we use integration by part. Okay, we use integration by part. Integration by part. Okay, if we are going to use integration by part, that means we need to calculate what is the uv. Okay, so for this we have to do the integration of x exponential minus 4x dx. We want to do this integration. Okay, so we are using the integration by part. That means we have to assume that we let u equal to x, then du equal to dx. right? And then we assume dv equal to exponential minus 4x dx. Then you take the derivation of this, then v is equal to exponential minus 4x minus 4. Okay, so this is can be used for the integration by part. We substitute into this integration over here. Okay, so we have a u v, so u is equal to x and v is equal to exponential minus 4x minus 4. So u v minus integration of the v du, v is exponential minus 4x minus 4 du is equal to dx. Okay, right? So let me note down what is integration by part, which is u v minus v du. Okay, you have to do this integration by part. So we substitute the u and v to this equation over here. Now we need to do the integrations of this one. So this is simple. We have x exponential minus 4x minus 4. So minus minus, we still have a minus 1 over 16. Then we have exponential minus 4x. Okay, so this is the integration by part. Now we replace this integration by part for this into this equation over here, then that will be our solution. So the general solutions, okay, so the general solutions, we have y 1 over the integration factor, which is exponential minus 4x, then multiply with the result here, we have x exponential minus 4x divided by minus 4, and minus 1 over 16 exponential minus 4x plus c. Okay, plus c. Right, so we can simplify this. Exponential minus here, we have x minus 4, and then we can cancel this out when we have minus 1 over 16, and then here we have a c multiplied by this is exponential 4x. Okay, so this will be our general solutions.